Hey guys, today we're going to be covering lessons 2.7 and 2.8. Both of them are short, easy lessons having to do with square roots. Okay, so lesson 2.7 is about calculating square roots. Now, normally, if you just had a square root that was like the square root of 9, you could just plug it into your calculator and get the answer. And even if it wasn't a perfect square, you could still just plug it into your calculator and you would get a fraction, or sorry, not a fraction, a decimal. But if the root is a fraction, you want to keep it in fraction form. And so the way that we do this is we convert the root of a fraction into the root of the numerator over the root of the denominator, and then solve the top and bottom separately. Also, just so you know, in BEDMAS, roots are treated like exponents, so they go second, just like division and multiplication. It's just like whichever comes first in the equation, because those are opposite operations. Same with addition and subtraction, whichever one comes first, that's one we do first, because they're opposite operations. Exponents and square roots are opposite operations, so whichever one of those comes first in the equation, that's the one that you would do first. Okay, let's just look at an example here of the root of a fraction. So if I had the square root of 4 over 9, I would rewrite that as the square root of 4 over the square root of 9, and then we just solve the top and bottom separately. So our final answer would be 2/3. Okay, if you were to just plug this entire thing into your calculator, you would likely get a decimal answer, like 0.6 repeating. But because it was given to us in a fraction, we have to answer it in fraction form. Lesson 2.8 is about estimating square roots. So this is when we are given the square root of a non-perfect square, and you want to solve it without using a calculator. So to do this, we use benchmarks. And for those of you that are not familiar with that term, benchmarks are just the two closest perfect squares. They're the perfect squares on either side of the number that we are trying to estimate. And this is something that you should have done in grade 8. So for example, if we needed to estimate the square root of 40, the benchmarks that we would use would be the square root of 36, since 36 is a perfect square and it is the closest one below 40, and also the square root of 49. 49 is the closest perfect square above 40. And so if we solve that, the square root of 36 is 6, the square root of 49 is 7. And these numbers here should be consecutive, so they should be in order. If they're not, you've missed a perfect square in there somewhere. What we're then going to do is see how far away 40 is from, our 36 and our 49, our two perfect squares. So 40 minus 36 is 4, so 40 and 36 are 4 units apart. And then between 49 and 40, we have 9 units. So negative 40 is closer by quite a bit to the 36 compared to the 49. And so we might estimate that the square root of 40 is 6.3. If these two numbers were equal, if 40 was exactly halfway between our two perfect squares, then it would be 6.5. If it was closer to the 49, it would be above 6.5 because we are closer to the 36. We're going to do below 6.5, so 6.3. Okay, let's look at how to estimate with decimals. Okay, if you're estimating the square roots of decimals, you start by converting the decimal to a fraction. Then, just like we did at the start of this lesson in 2.7, we are going to find or estimate the square root of the numerator over the denominator. So you separate them and do them separately. And then our last step will be to actually divide those two numbers that we get. So I'll show you an example of what that would look like. Okay, so I'm going to do the example of the square root of 4.9. Now, when we're starting with a decimal like this, again, we're going to turn this into a fraction. So the way that we do that is we write the 4.9 as a whole number, so 49. And then because this 0.9 is in the 10th position, as opposed to like the 100th, which would be the next position over, which is in the 10th position, so we put 4.9 over 10. And then the whole thing is still under our root sign. Then, just like we did in lesson 2.7, we're going to write this as the square root of 49 over the square root of 10. And then 49 is a perfect square, so I know that the square root of 49 is 7, but I'm going to have to come down here and estimate what the square root of 10 is. Now, the benchmarks that we would use would be the square root of 9, which is 3, and the square root of 16, which is 4. And then, obviously, 10 is much closer to 9 than it is to 16. So we might just say, okay, our answer here is probably like 3.1 or 3.2. Okay, so I'm going to estimate that that's, say, 3.2. Then we're going to take this entire fraction and actually divide it. So 7 divided by 3.2. And then because we are estimating here, I'm going to make this easier on myself and just take out that decimal or round it. In this case, 3.2 would round down to 3. If it was like 3.8, we would round up to 4. So 3 goes into 7 twice. That gives us 6. 3 times 2 is 6. If we subtract them, we have 1 left over. Put in our decimals, put in our 0, drop it down. Now 3 goes into 10 3 times. 3 times 3 is 9. We have 1 left over. If we were to do that again, we'd get the same thing. So it's 2.3 repeating. So our estimate might be 2.3 repeating. Okay, that is it for today's lesson.